Hello, everybody. Welcome back to geometry. We're in section 6.3, and I gotta say, 6.3 is gonna feel like deja vu 6.2 all over again. So if this feels familiar, you are absolutely on the right track because we've done this. It's opposite. Notice up here, I say if something is true, if you look at the bottom of this little table, then the figure is a parallelogram. In section 6.2, we said, well, if the figure is a parallelogram, then this has to be true. We're flipping it upside down. We're doing this backwards. We don't know if it's a parallelogram, so it might say, is this a parallelogram? And you're going to say, yes, because blah, blah, blah. So we're going to look for these reasons that it could be a parallelogram. So notice I've got this little parallelogram, or it looks like one, A, B, C, D. It's got the two diagonals drawn in, but we don't know if it is yet. So if both pairs of opposite sides are parallel, then the figure is a parallelogram. So if I go over here in this second column and I'm looking at this very specific example, A, B, C, D, so if both pairs of opposite sides are parallel, that's both, right? That's important. So I'd have to say that AB is parallel to DC, and AD, side AD is parallel to BC. In the last section, we would have known that because it would have the little parallel markers on it, right? It doesn't have it now, but if I tell you they are, then we can say, oh, well, ABCD is definitely a parallelogram. Now, I got to throw a little extra something in here in the first column, which is if we were looking at a graph, a coordinate plane, XY coordinates, I say graph these 4 points, tell me if it's a parallelogram, and I wanted to see if both pairs of opposite sides are parallel. What do you look for if you're looking for parallel lines or parallel sides, or what do you use? That would be slope, right? So if we were on a coordinate plane, we know that parallel slopes are congruent or the same. So I would know that the slope of AD is the same as the slope of BC. And the slope of AB is the same as the slope of CD. Now, that is the easiest way to do it. I'm going to put a little star here by this because if in doubt, use the opposite sides are parallel. That's the easiest way to check. You might be picking up a little hint here that we're going to do some coordinate planes. The second reason that you could say that this is a parallelogram is if both pairs of opposite sides are congruent. Notice, again, important, it has to be both pairs of opposite sides. So I could say that side AB is congruent to DC and side AD is congruent to BC. Everybody remembers that congruent means equal, right? So both of those things have to be true. There's an and there for a reason. It has to be both pairs of opposite sides are congruent. If we were on a coordinate plane, if we were looking for congruent, that means equal, right? The same length. We would have to do the distance formula, or maybe some of you are still using Pythag. Whoops, distance formula. To me, that's a lot of work. I would rather do slope, and I'm going to tell you in the assignment, if it tells you to do distance formula, still do slope. We're going to disregard those directions, go with slope. I don't want you to have to do more work. If you can show that the opposite sides, both pairs are parallel, do that. Don't use a distance formula unless you love the distance formula, and then go ahead and do that. We'd have to throw back a little bit, like to chapter 1 perhaps. And we've done it since. Here's another reason that you could say that a quadrilateral is a parallelogram. Both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. Again, there's a both there for a reason. So we would have to say something like angle A is congruent to angle C, and angle D is congruent to angle B. It must be both pairs and in the middle. There is nothing that we do at this point with angles on the coordinate plane, so I don't have anything to add. The only thing that we might do is if things are perpendicular, but we're not really thinking about that right now. So we won't do anything with the coordinate plane with angles. We'd have to pull out a protractor and start measuring. Our next reason that we could say that a quadrilateral is a parallelogram is if the diagonals bisect each other. The diagonals bisect each other. So this diagonal right here, AC, bisects this diagonal, DB. So I could say that AC gets cut in half, so segment AE is congruent to EC, and segment DE is congruent to EB. So the one diagonal cuts the other one into two congruent pieces. If we were bisecting each other, we could do distance formula on a coordinate plane to see if the segments are congruent, but there's a little bit easier, and the bisect would be the important part of that. So bisect means that we could look for a midpoint. If the midpoint of AC is the same as the midpoint of BD, that means they're bisecting each other and we have got ourselves a parallelogram. Sometimes that might be helpful. Midpoint formula isn't too tricky. I still think slope is easier because I can just count rise over run if I'm on a coordinate plane. Last reason that quadrilateral is a parallelogram is if one pair of opposite sides is congruent and parallel. The same pair of opposite sides is congruent and parallel. I'll put same right here. So we could say opposite side, parallel, and congruent. So I could say something, did I move that down there? No. I could say something like side AB is congruent to DC and AB is parallel to DC. So the one pair is opposite and congruent. If that happens, then it is a parallelogram. Now, I just picked the top and bottom, AB and DC, but I also could say that if I was given the information, this is an OR right here, if AD was, let's see, AD is congruent to BC and AD is parallel to BC. So one of these two things is true. Either the top and the bottom is parallel and congruent, or the two sides are parallel and congruent. Then we know that we've got ourselves a parallelogram. So there's not a whole lot of different. We're just asking in the opposite way. We don't know if it's a parallelogram. So the first couple examples are asking, determine if this is a parallelogram. It's a yes or no question. But if you know me at all at this point, which hopefully you do because we've been together for a semester, I want you to explain it. Not just because it looks like it, but because you have some evidence. Your explanation is going to be one of those reasons from the table that we just went through. So in letter A, I've got a quadrilateral, a four-sided figure. Notice I've got 12 centimeters on the top and bottom, 5 centimeters on the two sides. I've got yes because both pairs of opposite sides are congruent. Both pairs of opposite sides congruent. It's important, the both is important, and the congruent is really important. Because remember, we did have the one option where one pair of sides is perpendicular, or is congruent and parallel. Letter B is a trick. Letter B is a mix and match, right? We know that we've got one pair of opposite sides. Whoops, one pair of opposite sides are congruent because I've got my congruent marks. I've also got one pair of opposite angles are congruent. But is there one of those choices on our chart that we just filled out? There's not, right? One pair of opposite sides is parallel and congruent, but that's not the case. Both pairs of opposite angles are congruent, but that's not the case because we don't know these two angles. They might look congruent, but if there's nothing there, do you know that they're congruent? Right? We don't know. Looks like it, but I don't know. So if I say determine if this is a parallelogram, what are you going to say? No, and I would just use the reason not enough info. I either need to know the other pair of angles are congruent or I need to know something else about the sides. I can't mix and match. So remember, this explain is going to be one of the rules from the table that we just filled out. And if there isn't enough, it just doesn't fit any of the rules, you're going to say there's just not enough information. We cannot tell for sure. So we can also do some algebra with this because I know that you still like doing algebra. Notice the question is asked the opposite way. It says find x and y so that FJHG is a parallelogram. Well, in the last section, we said if this is a parallelogram, find x and y. No matter which way we ask the question, we're going to solve it the same way. So if this is a parallelogram, all of my x and y information, here I've got an x information with a 6x plus 3. Here I've got a mixed and matched 4x minus 2y, but it's all on the side. So I'm going to use the side information in a parallelogram. If this guy is going to be one, the opposite sides, both pairs have to be congruent. We've got ourselves a setup. In class, I would ask you which set do you want to make congruent first and solve? And I'm betting that you're going to tell me this one because the 4x minus 2y already has an x and a y in it. So I'm going to set this guy up. 6x plus 3 equals 15. Should be a pretty quick and painless solve. If 6x equals 12, I'm hoping you agree with me that x equals 2. So now we're going to find y. We know that these two sides are congruent. So I'm going to do 4x minus 2y has to be equal to 2. We just found that x was 2, so we're going to substitute that. So remember, we multiply these. 4 times 2 is 8. 8 minus 2y equals 2. Negative 2y has to be equal to negative 6. So I believe that's going to give me a positive 3 for my value of y. So you just have to use, if you mess up on your x, you're not going to get the right answer for y. So solve carefully, make sure you know where to go first. All right, so far easy, right? I'm trying to talk quick. Feel free to pause if you need to. Number 3, we should just mention. And let's fill in the diagram. So it says, if all this business, find x and y so that the quadrilateral is a parallelogram. So again, it asks the similar question to what we did in the last section. If we want it to be a parallelogram, we know we've got these things. So it says that FK is equal to 3x minus 1. That is a part of that diagonal FH. KG is 4y plus 3. JK is 6y minus 2. And KH is 2x plus 3. Well, if I look at my table, what does it say about diagonals? I've got the diagonals bisect each other, right? So we know that each diagonal gets cut into 2 congruent pieces. So I know that JK is going to have to be congruent to KG. And I know that FK has to be congruent to the other half of that diagonal, KH. So then we can substitute values in there. Is everybody okay with solving that? Do I need to go through that example? I think you should be good, right? Also, I know some of you are going to be like, well, I'm just going to set the x stuff equal to each other and the y stuff equal to each other. Well, that's a strategy, but just be careful because it doesn't always work. So, all right. Same kind of question. Find the value of x and y so that it's a parallelogram. I'm just picking out different things from the table, from the rules table. In this one, my x and y information is all in the angles, right? No side information. But if I look at that table, it says both pairs of opposite angles are congruent. So I know that this has to be congruent to this. And I know that this obtuse angle right here has to be congruent to that obtuse angle. I've got myself an easy setup, and I can solve for x and y pretty quickly. Number 5, opposite sides, both pairs have to be congruent. Please let me know if I skipped over too many examples, but I feel like you know what you're doing. So let's do one more example, maybe, yeah, one more example, I think. So determine if this is a parallelogram. Justify your answer or by showing that both pairs of opposite sides are parallel. I kind of gave you a huge hint here. I don't think in the book it's going to give you such a large hint. So justify your answers by showing that both pairs of opposite sides are parallel, which means we're going to need to use slope. Remember, slope is rise over run, or subtract the x's over, subtract the y's over subtract the x's. I think it's easiest to graph it, so let's graph these 4 points, label them, and then we'll connect them and make a parallelogram, or a quadrilateral that we think is a parallelogram. So A is at 3, 3. Make sure you put your points on there. B is at 8, 2. C is at 6, negative 1. Oops, my board's a little off, so, oops. Now it's off the other direction. Maybe it's me. 6, negative 1 is C, and D is at over 1, up 0. So I hope that your quadrilateral looks a little better than mine. Mine's sloppy, but hey, it's a mystery, right? Does it look like a parallelogram? Is it supposed to look like a parallelogram? Mine's kind of a mess. In the book, please use the slope method only. You don't have to use distance formula. If you know how to do this with slope, and I think it's shorter and easier, then only use slope for any of the work, quizzes, whatever. Use slope only. Unless you want to do it a different way. Again, sometimes you might need to use diagonals, but we can use slope. So what I need to do is I need to find the slope of all 4 sides. So I've got the slope of side AB. I've got to find the slope of side BC, the slope of CD, and the slope of AD. Now I'm going to count rise over run. If you prefer to use the formula, subtract the y's over subtract the x's. You like a formula, plug it in quick, you can definitely do that. Remember, if you're finding the slope of AB and you're using the formula, you just use A and B, you ignore C and D. If you're finding DA, you just use D and A. So just be careful on that. All right, if I count rise over run for AB, it looks like I go down 1 and right 5. Is that right? Down 1 and 1, 2, 3, 4, 5. So down 1 and right 5. My slope of BC, it looks like I go down 1, 2, 3 and left 2, or negative 3 over negative 2, negatives cross out, 3 over 2. Remember, I'm going to leave that as an improper fraction. From D to C, I go down 1 and right 5. And AD, to get from D to A, it looks like I'm going up 1, 2, 3 and over 2. So is this a parallelogram? It's still a yes or no question. Determine if this is a parallelogram. I asked you that question for the first 2 examples. Yes, this is a parallelogram, right? Justify your answer. What do you see? I see AB and CD are parallel, and I see that BC and AD are parallel. So both pairs of opposite sides are parallel. We've got ourselves an answer, and we are done on that one. It's not difficult. It's just pulling in a lot of stuff. We did slope way back at the beginning of the year. We have a lot of things. In the assignment, number 20, please be careful. It does have a system of equations, so x's and y's. Remember, we reviewed that when we started off doing algebra, so you might need to go back and look at those systems or ask me about it. That was number 20. Otherwise, that is it for section 6.3. Thanks for hanging in there. I hope that you find this section easy. Come in with any questions and I am more than happy to help. I'll see you guys next time.